everyone, a fourth degree polynomial has zeros at -3, 3i, and -i. Which graph could represent the function defined by this polynomial? So basically, they all go through these two zeros. What I want to do is go ahead and write out the polynomial. So this would be actually x minus a -5 times x minus 3 times x minus I times x minus a -i. All right, there's the I. So, again, this would be just x plus 5, x minus 3, and these two negatives right here are going to make a positive. So I'm just going to make it a positive here. And when you group these together, normally it's basically when you do a minus bi times a plus bi, that gives you a squared plus b squared. Because the square root of I is going to be -1. Or not the square root, the square. So that's what we get there. So this is just going to be x squared plus 1. All right. Now, since we have that, the next thing you need to know is that this is degree 4. Well, degree 4 either opens, the end behavior is either going to open up like this or open down like this. It opens down if it's negative, but ours is positive. So our end behavior is that it's going to start in quadrant. If you're graphing from left to right, we're starting in quadrant 2 and we're ending in quadrant 1. So that would be either this graph or this graph. So these two graphs are not it. So we're going to look at this, and the only thing we need to look at is this y-intercept. So to get your y-intercept, you let x be 0. So we're going to do p of 0. And that's going to give you, that should be a comma there, 0 plus 5, 0 minus 3, and 0 squared plus 1. That gives you 5 times -3 times 1, which is -15. So when x is 0, y is -15. That means it has to hit down here somewhere. It can't be this one, because that would be a positive number. So our answer is this graph right here. And that's it. Thank you. Have a nice day. Bye-bye.